Hi, my name is Ronit Mukerji. I'm an applications engineer within Yokogawa's test and measurement department. Today, I'm going to show how to collect data from a WT500 power analyzer using the GA10 data acquisition software. This software can monitor up to 100 Yokogawa devices independently. However, for most WT series power analyzers, an external piece of software called the GA10 is needed. The GA10 acts as a server between the power analyzer and the GA10 unit. For this demonstration, I'll use my laptop as the load and monitor the power consumption through a custom load box designed to connect with the WT500 power analyzer. The first thing I'll show you is how to set up the electrical connections of my load, which is a laptop, and the custom load box to the WT500. I will then set up the Ethernet communication connections between my laptop and the power analyzer and verify the validity of the connection. Lastly, I will set up the GA10 and GA10 software to monitor data acquisition using custom displays to read the power consumption variables for the WT500. Okay, so here I have a power strip, a custom load box, the load, which is my laptop, and an Ethernet cable, all pre-wired for a quick demonstration. To give you an overview, the main supply voltage, ideally 120 volts AC at 60 Hertz, is going into my load, the laptop, via the AC out. Power from the wall is going into the load box via the AC in. The load box has breakout leads that can connect to the power analyzer's inputs so that we can monitor the power being consumed by my load. As seen here, the voltage leads and the current leads. When making these connections on your end, please always make sure the circuit is not live when connecting. Otherwise, you could cause damage to the equipment and, more importantly, yourself. Next, now that I have all the electrical connections complete, I'll connect the main supply voltage to my load box by turning on the power strip. With the hardware connected and powered, we're ready to set up the network and software connections to make measurements. Okay, let's get started. First, let's set up the communications between my laptop and the WT500 power analyzer. I have a crossover RJ45 Ethernet cable connected to my laptop on one end and the WT500 on the other end. On your setup, you may have a network switch, in which case you'll have to use a straight RJ45 Ethernet cable, but the underlying principles will be the same. Next, I'll configure the IP address for my laptop. I'll navigate to Windows and search for the network connections. This will bring up a list of all available wired and wireless network connections. Find the connection that corresponds to your Ethernet port, in my case, a local area connection, and right-click and select Properties. Choose IPv4, select Properties. We will assign our laptop the address of 192.168.10.20. Leave the subnet mask at 255.255.255.0. Click OK. Next, I'll configure the IP address of the WT500. Here we are at the WT500. First, we will select the MISC, Miscellaneous button, select Network, and then select TCP IP Setup. This brings up the IP configuration menu for setting the IP address of the instrument. Set DHCP to off, and then in the IP address menu, set the device's address to 192.168.10.200. Set the subnet mask at 255.255.255.0, the same as it is on the PC. Finally, click Bind to save the changes. Next, we will ping the device from our test PC to make sure we have proper connectivity between the PC and the power analyzer. We will hit the Windows key and type in CMD. This will open up the command line interface. Next, we will type in ping 192.168.10.200. If all prior steps were followed properly, we should get a response back from the WT500. Now that we have a working successful Ethernet connection with the power analyzer, our next step will be to set up the software pieces. The first software element we need to set up is GA10. This establishes connection with the WT500 power analyzer. I will select Run it as administrator. Remember to always do this, otherwise the application will not have write access to its folders to save configuration changes. Select cell 1, click the COM type drop-down menu, and select Ether. Next, select the address cell and type in 192.168.10.200 in the IP address bar in the input address pop-up. Click Save. Next, I select Auto Determination to make sure the WT is identified. On my end, it is assigned model WT500 and space brackets 3. I'll then scroll to scan interval settings. This determines how often the gate WT registers or reads data from the WT500. The minimum scan interval that can be set is 500 milliseconds. This will be important later on. I click Save again, and then I start the gate WT server by clicking Execution under the drop-down menu. Gate WT is now connected to the WT500 and is reading data from the power analyzer. Next up, we will set up the GA10 acquisition software. Since I've created an account before, I will log in. But if this is the first time using the software, leave all fields as default. We'll then go to File, New Project. I will title it WT500 Demo and select Detail Settings. Selecting Item 1, we will then register the WT500 device. Click Register Device Type and type in the entry under WT Model from the Gate WT configurator as the device name. For the host name / IP address, this will be set to localhost. Once registered, we will then go to the tag page and select the relevant tags and assign them comments. We will monitor 4 variables from the WT500. I will select Monitor and Record for items 1 through 4. I will then select tags 1, 6, 14, and 11. These correspond to Phase 1 RMS voltage, Phase 1 RMS current, power factor, and Phase 1 real power. As such, I will also assign the relevant comments to each tag. Lastly, I will go to the display and confirm all tags are set up to be displayed on the GA10 graph. I will title it Phase 1 Power. Now I'm going to adjust the min and max scale. These settings may not be entirely correct until we actually see the data coming in, but I just wanted to highlight how to be able to do that. Next, I'm going to assign a value for the y-axis scale for each tag. I try to be as consistent as possible in the naming scheme, so I'm going to assign it the same name that I assigned each tag originally. These values will show up on the y-axis scale, on the graphs, as well as the indicators on the plot that we'll see later on. I will then navigate to Acquisition and Monitor. I will use device time. As described earlier, the GA10 will then acquire data from the gate WT every 500 milliseconds, the rate at which the gate WT monitors the WT500. We are finally ready to hit Start Monitoring, which will launch the monitor page and update the display. We can now customize the display as we see it fit by adjusting the grid type, magnification, line thickness, scale, alarm condition, and color, all while monitoring is occurring. This can be done by selecting the wrench icon, selecting Display and Display Group. Additionally, the layout can be adjusted by navigating to Acquisition and Monitor and adjusting the number of panels as well as the horizontal versus vertical layout. Right now I'm adjusting the line thickness as well as the grid type. I choose the thickest line possible to differentiate each signal and change the grid type to have more squares on the screen. Next, I'm going to readjust the scale since Phase 1 RMS voltage is at the high end. I want to be able to show that signal on the lower end. I'm going to go back to Display Groups to change that value from 120 to 150. And I go back, and you can clearly see the signal is now within the range, and it's easier to see. In conclusion, I want to offer a quick review of what we discussed. We made all proper electrical connections from my load to the custom load box and the WT500 power analyzer. We established and verified communication connections from my laptop to the WT500 power analyzer using Ethernet interface. We set up and established connectivity between the power analyzer and gate WT for GA10 software, which acts as a server that communicates with the WT500 via TCP/IP. This server is needed for the GA10 to read from it. Lastly, we registered the device in the GA10 software and set up custom displays for monitoring variables from the WT500. Thank you for watching. For any inquiries, please don't hesitate to contact an applications engineer or visit us at tmi.yokogawa.com.